All right, welcome back. We start chapter 3 today, and we'll split this up into, it looks like 3.1 will split up into two sections here. And so we'll cover the first one, video 3.1a, and as we take a look at this learning targets, what we're looking for. In the first part, we're going to be looking at, to decide what is an explanatory or a response variable and make scatter plots. Then we're going to be able to describe the direction, form, and strength of relationship displayed in the scatter plot and identify any unusual features. We'll talk about correlation and causation, those types of things, in the second part of the video. So the first thing that we want to do is take a look at, we have a one variable data set is sometimes what we call univariate data. If it's between two variables, we call bivariate, uni meaning one, bi meaning two. So analysis of relationships between the two variables builds on the same tools we use to analyze one variable. So we're going to plot the data, look for patterns, add some numerical summaries, and then when there's a regular overall pattern, use a simplified model to try to describe it is what we're going to try to do. So most statistical studies examine one or more variable. And analysis related between two variables builds on the same tools that we used for one. So a response variable measures an outcome. An explanatory variable may help predict or explain changes in that response, a variable. So in many studies, the goal is to show that changes in one or more explanatory variables actually cause changes in the response variable. However, other explanatory response relationships don't involve direct causation, so sometimes that can be easier said than done, as we say. So a scatter plot, this is something we've seen before, shows the relationship, the association between two quantitative variables measured on the same individuals. Now, the values of one variable appear on the horizontal axis and the other on the vertical, and each individual in the data set appears as a point in the graph. So what you want to do is label the axis. Now, the explanatory variable should go on the x-axis, the horizontal. The response should go on the vertical. And if there's no explanatory variable, then either one could go on either. It doesn't matter. You want to make sure you scale the axes and then plot the individual data values. Is what we want to do. From this, now what we want to do is look for patterns and especially important departures from those patterns. Now, we're going to say that two variables have a positive association when above average values of one variable tend to accompany above average values of the other, and below average values tend to occur together as well. Now, there's a negative association when above average values of one variable tend to accompany below average values on the other. And then there's no association if it's kind of random. It's knowing one variable has there's no really able for us to predict the value of another. So here are some examples looking at a graph. The first one here, you can see kind of has a positive trend, and we'll talk about, the strength of it is, it's so-so. The second one here has a negative association. You kind of see as one variable goes up, the other goes down. And then this one, of course, would be kind of random, and there's really no association whatsoever. There'd be no way to predict what would happen. So that's kind of what we're looking for. Now, other things to do as we try to look at this, how to describe it is we're going to look at the scatter plot. Is it positive, negative, or no association? Is it strong, or is it a linear one? If it doesn't form a line, then we would say it's nonlinear or it's curved. And then the strength. Now, if it's really tight about the line, we'd say it's pretty strong. If it's pretty loose about the line, we'd say weak, or moderate would be another way to say that. So we'd have that. And then always look for those features, like those points that are kind of outside where the pattern is, and look for those, or distinct clusters. If they're kind of bunching up in one area, that'd be a good thing to describe. Now, remember, when describing the association, right in the context of the problem, make sure you're talking about what it is. So just saying, there's a strong correlation between this and this, so make sure you use both variable names when you're talking about the description. So when you're doing that. All right, so here's an example. Scatterplot shows the association between mean SAT math score and the percent of students who take the SAT for the 50 U.S. states. Describe the association shown by the pattern. Well, take a look there. You can see when the percent of taking the SAT is low, the average score is higher. And when you have in the percent of more people taking it, it goes lower. Well, you can kind of maybe see why. It doesn't really say to describe why, but obviously what's happening in some states is they're taking their high-end people for the SAT, and the lower-end people are not. Therefore, you can see that association here. So to describe the data, there is a moderately strong negative. You know, if we were to draw a line through there, you could kind of see, yeah, that's pretty tight about that line. There's a curved relationship. It doesn't look like it's really straight, so kind of curved or nonlinear between the percent of students in the state who take the SAT and the mean SAT. Now, notice the context of that description there. You know exactly what the variables are. Further, there are a couple of distinct clusters. There seems to be kind of a cluster in that first part, and then the second part, like after you get around 50, 60, 70%, there seems to be a cluster there. And then there's two unusual points that fall outside the overall pattern. You can kind of see those, you know, kind of when the percent is 20, there's that low one there, and then when the percent gets close to 90, you can see that really low one there as we see that. So again, we can see that we talked about the strength, the direction, so negative, positive, or no association, the form, so it's nonlinear or curved, and we also talked about unusual features. So those are the things that we would talk about when describing scatter plots. So there's an example. You try a few yourself now, and then we'll come back tomorrow and talk a little bit about correlation. Until then, I'm Mr. Boone.